Welcome back to the Punny Math Teacher. So remember, expectations, use twice this video's length. I'm trying to keep it between 10 and 15 minutes, so twice would be 20 to 30 minutes. To take notes, make sure you can read your handwriting and you can read it later because these are notes to your future self, so make sure you can understand what you wrote the first time. And then again, I have a Google site here for extra help and resources. So today's objective, we're going to graph solution sets for one variable inequalities, but we're going to up the game a little bit. We're not going to just do the basic b is greater than 4. We're going to do a little more complex stuff with solving and isolating our variable first, so it's like equations, and then we will get into graphing what solutions that we're left with. And to our thingamajiggies. Okay, thingamajig meaning table of contents. So we're already on our third unit. Again, this one is just 2 lessons for videos. It's a lot of practice, but it's really familiar things because a concept is based off of equations. So we spend a lot of time on equations to build up to just this unit so you can understand inequalities better. Today we're doing compound inequalities, so we're extending it and moving on to page 18. And the colors I originally used were orange and purple. So let me go get some orange and purple. There's purple and there's my orange one. Okay, I have my markers. So we're going to divide everything into 6 boxes. So take your whole piece of paper, we're going to split it in the middle, woo, and then we're going to split it into 3 rows. So that's what we're doing with our notes, is splitting this into 6. As best as you can get. They don't have to be perfect, but that's our goal. So we're going to title this left-hand side the and side, and the right-hand side the or side. So compound is kind of like compound words. Hot dog, race car. It's 2 words put together to make a new word. We're going to combine 2 inequalities into 1 inequality and graph it on 1 single number line because it's now all 1 solution set together. So for ands, our goal is to shade the intersection. And for ors, we're going to shade the union. And since a union means joining things together, this really means just both. Okay? Or where they overlap. Like, not where they overlap, it's everything. Intersection is where they overlap. So it's the overlap only versus shading the union is both of them, where they overlap and where they don't overlap, where they're just singles. Okay, so we are going to start off with just what does an and typically look like? This is typically an and. We can actually combine them together into 1 singular inequality expression where you can see them. So this means that x is greater than or equal to 3 and x is less than or equal to 7. So look how we broke it apart. We kept the x less than or equal to 7, woohoo! But we also took this half, this 3 is less than or equal to x, and we had to flip everything, just like I did at the end of our notes last time, and just like you did because you wrote it down, right? We flipped it, so the 3 and the x switch sides, and the symbol gets flipped. So instead of less than or equal to, it turns into a greater than or equal to. And now I'm going to graph this, and if you want to graph it with 2 different colors, you're welcome to. And again, we have 3 numbers that we care about, always starting with 0 so we can tell where our positives or negatives are, and we care about 3 and positive 7. So I'm going to use an orange marker and use a purple marker. So when x is greater than or equal to 3, that is like a number line starting at 3. Yes, this will be a closed circle, starting at 3 and going all the way to the right. So that's why I'm starting with 3 and going to the right with my marker. When x is less than or equal to 7, that's the same as a marker starting at 7, yes, a closed circle, going to the left because it's all less than 7. Where these overlap is what actually gets shaded. So these are going to overlap, including 3, including 7, and then everything in between. That's where these 2 markers overlapped. This is the intersection, and that's the and. These are both closed. Yeah, I don't know why I wrote that. Anyway, they're both closed, and that's the intersection, is where they both overlapped. Put whatever notes to yourself that you need to make sure you remember what that actually meant. Okay, Next one. So now we're actually going to solve these and simplify. So example 1, this will be example 2 down here if you want to prep that. Okay. Example 1, negative 2 is less than or equal to x minus 3 less than 4. So we see it all together in 1, which is a possibility. That means I need to solve it as all 1. And we actually, it's fun because there's 3 sides now. We're used to like 2x plus 3 equals 5. Well, there's 2 sides, the left side of the equal sign and the right side of the equal sign. We now have 3 sides. We have a left, center, right. Woo! So I want to get this x all alone. I need to undo this minus 3. So how do I undo a subtraction of 3? I'm going to add 3, but I have to do it to both sides. Well, I have 3 sides, so I have to add it over here to the negative 2 and to the positive 4. And then I draw my big long equal sign, and we get that. All right. Woohoo! So now I'm going to have, it's as simplified as I can get, just like this first one that we had up here. So this actually means that I need x is greater than or equal to 1 and x is less than 7. That's what this means. You don't have to rewrite it out like this. The goal of a compound inequality is to be lazy and keep it in the compound form. All right, so I can leave it here. I know that when I graph this, I need a 0. I care about the 1 and the 7. I put a little more space in between just because there should be kind of some scale, but we labeled it, so it's okay. We're not looking for scale. We're looking for where is the solution set? What numbers or what values can I substitute for x here that are true? So if I plug in 3, is 1 less than or equal to 3? True. Is 3 less than 7? True. That means at 3, that is a point. That is a valid solution. What about 8? Is 1 less than or equal to 8? True. Is it also 8 less than 7? No. 8's not a solution, so I'm not going to shade anything out here. And at this point, we actually know that 7's going to be an open circle and 1's going to be a closed circle just based off of our symbols. What if I plugged in 0, substituted 0? Is 1 less than or equal to 0? No. So all of our solutions are only in between 1 and 7, including 1 but not including 7. So you can use the markers, how I have them overlap on the last one, or you can think about which one numbers actually make sense. Where is my solution set? All right, and I'm going to switch markers back to orange for example 2. Example 2. Now sometimes we don't actually see it as a combined inequality. There we go, just enough room. So sometimes we see it literally with the word and there, and in this case we can treat it just as 2 separate inequalities. So I'm going to add 3, but only to the both sides on this inequality over here. Now yes, it happens that I add 3 over here as well, but I'm solving one at a time. All right, so this turns into y less than or equal to negative 8. I'm going to bring down the word and now I'm going to solve this one over here separately. Okay, and now I have 2 separate inequalities, which I could combine them if you wanted. So to combine them, y goes in the middle, the smallest number is negative 8, the largest number is negative 5, and y is less than or equal to negative 5, but because I switched the order, I flipped them, I have to also flip the sign, the symbol. So this is a way I could write it combined from 2 separate ones once I get them isolated. So when I graph this, I care about 0, negative 5, negative 8. Notice I put the 0 way over there. That's totally fine. I know that both numbers I care about are negatives, so that's what I'm going to focus on the most. Close circle, it's an and, so it's in between. All right? I'm going to go a little faster through the ors now that you know how to find solution sets. So for our or, we're going to start with x is greater than 2 or x is less than or equal to -1. Typical ORs, we split them up. We actually see the word or. Ands are possible to combine into one and make it look pretty so it makes sense and easy to read. It's not as simple to read when we combine them for the ORs. So when I graph this, I have a 0, I care about a -1, and a +2. Make sure you understand where those numbers are coming from, why I'm able to put them down so quickly. Based off of my symbols, I know this is an open, this is a closed. Can you figure that out on your own? And now I want both of them. So I'm just going to graph both as typical. So if I only had this left-hand side, it'd be greater than. If I only had the right-hand side, it would be less than. Done. Okay? Example 1 and example 2. That's 1. Example 2. All right. So I'm going to write this. It's going to take up some room. You may want to pause once I write it. Greater than 37. There we go. Those are our two that we are going to solve. So I'm only solving one at a time. So I'm going to subtract 7 on both sides. 2m less than or equal to 6m less than or equal to 3. Bring down the or, subtract 12, 5m greater than 25, divide by 5, so m is greater than 5. All right, I care about positive numbers only in this case, so I'm going to move that 0 over. Try to graph this on your own. Pause it, figure it out. It's a closed circle, open circle. Ors typically go out, but I want to check this. Okay. M is less than or equal to 3, okay, or m is greater than 5. Okay, then I'm good. So you can do a straight arrow if you want. I typically do squiggles just so you can see them above the number line in case you're using all one color, and then it's really difficult to tell. Okay, example. Oh, did I do that right? Oh, I didn't. Okay, and this is our fix because I know I messed up on purpose. And this one's not on purpose, really. But I want to catch it. So I'm going to use a different color to check this. This is a -2. If you draw a negative, make sure you bring that negative with you. Now, when I divide by a -2, this is not what I get. I should get m and a -3. And when you divide or multiply by a negative, we have to also flip the symbol. So it's going to be greater than or equal to -3. In my resources on my website, I'm going to tell you how to Google search to find an activity that will help you realize why this works. All right? I can't do it because it's not my activity, but it's a great activity for you to work through and figure out why do we even flip the symbol? Because flipping the symbol messed this whole graph up. All right, so let's redo this graph. And math is about redoing. Even if you have pens and markers, you don't have to erase. But I like this now because I actually can see my mistake. If I erased it, I'd never see what I did wrong. So I can learn from it. Okay, so again, I have a 0. Ooh, but I have a -3 now and a +5. I know it's a closed circle for the 3 and open circle for the 5. But now I want to think about this. Because an OR graphs both. So if I graph greater than 5 and I graph greater than or equal to 3, notice how they overlap. 5 is now actually part of the solution, and that's okay because it's true for this. 5 is greater than or equal to -3, but 5 is not greater than 5. So even if it's false for one of them, it can be true for the other, and that's okay. So that's an OR. Either one could be true or both can be true. And both must be true. And that's a huge logic thing in math. If it says or, if it rains or snows tomorrow, we have a quiz. That means if it rains, we'll have a quiz. If it snows, we'll have a quiz. If it snows and turns into rain, or rains and snows at the same time, we'll still have a quiz because both were true. Now, if it rains and snows tomorrow, we'll have a quiz. Then you only get a quiz if it rains and snows, whether at the same time or during the day, whatever the condition was. But as long as it did both, and then you get the quiz. All right, so example 2. I know I'm 29 seconds. Okay. Okay, so I have x greater than or equal to 9 or 2x. Sure. I just changed this up because I read it wrong. So let's see what happens. Okay. So I'm going to solve this. Subtract the 4. 2x less than 6. X is less than 3. So I'm going to be graphing this. X is greater than or equal to 9 or x is less than 3. So this is one of your typical ors, and that's why I was like, okay, this is an okay example for example 1. Again, they're only positive numbers. What circles are they? Are they open or are they closed? This one's going to be closed. This one's going to be open. Okay, I want to graph both of these. So I'm going to be greater than 9 and then less than 3. This is a typical OR. They're going out away from each other. But sometimes you're going to get ones that do overlap. So I wanted to make sure you had an example like that. And that's what clued me in that I made a mistake, because this isn't what I wanted you to see. Okay. Let's go back for your comprehension questions. Pause this, figure it out. What are the two types? Why are they sorted? And how are they different than equations, or how are inequalities the same? So thank you for watching. We made it just over 15 minutes. Have a great day. Bye.